I want you to do something for me. Hold out your arm, fully extended, palm facing up. The entire history of this planet, 4.5 billion years of fire, ice, monsters, extinctions, and life, fits on that arm. The first life appears somewhere around your shoulder. The first complex animals appear near your wrist. The dinosaurs arrive at your fingertips. And the entirety of human civilization, every empire, every war, every invention, one. Every person you have ever heard of fits in the thin layer of dead skin cells that fall off when you drag a nail across your fingertip. One stroke of a nail file, that's us. That is the scale of what we are about to explore. Not in a dry textbook timeline, not in a list of dates and eras. We are going to feel this history, the heat of a planet that was once entirely molten rock, the silence of oceans with nothing alive in them. The moment the first predator opened the first mouth and swallowed something that was still alive. And the moment a small, terrified, nearly extinct primate stood up on two legs in the middle of a savanna, surrounded by animals that could kill it in seconds, and decided, for reasons evolution had never tried before, to think its way out. This is the story of everything, in 20 minutes. Stay with me. 4.5 billion years ago, there was no Earth, not yet. What existed was a cloud of gas and dust rotating around a young star. Our sun slowly pulled inward by gravity, colliding, heating, compressing. Over millions of years, this material coalesced into a sphere of molten rock. The surface temperature exceeded 2,000 degrees Celsius. The sky, if you could call it that, was a toxic curtain of sulfur, carbon dioxide, and superheated steam. There was no ground to stand on. The entire surface was liquid magma, churning in slow, violent convection currents. This was Earth. Year zero. And then, approximately 50 million years after formation, something hit it. A planet the size of Mars, astronomers call it Theia, was on a collision course that gravity had been preparing for millions of years. There was no warning, no gradual approach. At the scale of geological time, it was instantaneous. Theia hit the early Earth at a speed and angle that could not have been more perfectly catastrophic. The energy released was so enormous that both planets were partially vaporized. Theia's iron core sank into Earth's mantle, merging with our core, making our magnetic field stronger than it would ever have been without the collision. The outer layers of both planets were blasted into orbit, forming a ring of molten debris around the wounded Earth. Over thousands of years, that debris coalesced. The Moon appeared. And this matters not just poetically, but physically. The Moon's gravitational pull locked Earth's axial tilt at 23.5 degrees. Without that lock, our planet would wobble unpredictably. The poles would shift. The climate would vary so chaotically and so rapidly that complex life would have had no stable foundation to develop on. The collision that nearly destroyed Earth also created the conditions that allowed life to exist. The universe has a sense of irony. After the Theia collision, Earth began to cool. Not quickly, not gently. The process took hundreds of millions of years, the surface temperature dropping degree by degree, the churning magma surface slowly hardening into a thin black basalt crust, constantly cracked and remelted by the volcanic activity beneath. But as the temperature dropped toward a critical threshold, the boiling point of water, something changed in the heavy, toxic atmosphere above. Water vapor, outgassed from volcanic eruptions and delivered by the constant bombardment of comets and asteroids, reached saturation point. Clouds formed. And then, for the first time in Earth's history, it rained. Not a storm, not a seasonal event. A rain that lasted approximately 1 million years. Water cascaded from a sky that had never before produced a single drop, filling meteorite craters, flowing across volcanic plains, accumulating in vast, shallow basins. When it finally stopped, Earth was covered in ocean. Brown, acidic, mineral-rich ocean, under an orange sky, still thick with carbon dioxide. No sound except waves against volcanic rock. No movement except the current. No life. But the stage was set. The water was there. The chemistry was there. And deep beneath those first oceans, something extraordinary was about to happen. Go deep, thousands of meters below the surface of that first ocean, where no sunlight has ever reached, and the pressure would crush any modern submarine. Here, the ocean floor is cracked. Seawater seeps into fissures, contacts magma chambers below, superheats to hundreds of degrees, and blasts back upward through hydrothermal vents carrying with it a mineral-rich soup of hydrogen sulfide, iron compounds, and carbon-based molecules. At the boundary between boiling and freezing, between the superheated vent water and the near-zero temperature of the deep ocean, something was happening. Chemistry. Billions of random chemical reactions, colliding continuously for tens of millions of years. Carbon, hydrogen, oxygen, nitrogen arranging, breaking apart, rearranging in combinations that had never existed anywhere in the known universe. And then, at some moment that we cannot pinpoint, that will likely never be pinpointed, a specific arrangement of molecules folded itself into a membrane, enclosed itself, created an inside and an outside, and most critically copied itself. The first living cell, everything alive on this planet today, every bacterium, every fungus, every plant, every insect, every fish, every mammal, every human being watching this video descended from that one cell. We are all cousins at the deepest possible level, the blue whale and the oak tree and the mold on your bread, and you share a common ancestor that lived at the bottom of a Precambrian ocean nearly 4 billion years ago. Life began once, and it never stopped. For 1 billion years after life first appeared, nothing much changed. Single-celled bacteria dominated a world that had no predators, no competition, no complexity. They floated in the ancient oceans, eating chemical compounds, surviving, dividing. The planet was alive, but barely. And then, approximately 2.4 billion years ago, one lineage of bacteria made a discovery that would change the planet permanently. Photosynthesis. Cyanobacteria blue-green algae learned to harvest sunlight directly, converting carbon dioxide and water into sugar and energy. They became extraordinarily successful. They multiplied across the surfaces of the ancient oceans in vast microbial mats, carpeting shallow coastal zones. And, as a byproduct of photosynthesis, they released a gas: oxygen. Here is the problem. Before cyanobacteria, oxygen was essentially absent from Earth's atmosphere. And for every organism that had evolved in the absence of oxygen, it was not a life-giving gas. It was a poison, a highly reactive, cell membrane-destroying, DNA-damaging poison. As cyanobacteria population exploded, they pumped billions of tons of oxygen into the ocean and then into the atmosphere. A global massacre began. Anaerobic bacteria, organisms that had dominated this planet for over 1 billion years, were killed in vast numbers wherever oxygen spread. The sky turned from orange to pale blue, and the planet froze. With oxygen destroying the methane that had been keeping Earth warm, global temperatures collapsed. Ice sheets formed at the poles and advanced toward the equator. The oceans froze solid kilometers deep, from pole to pole. For approximately 300 million years, Earth was a completely white, completely silent, completely frozen ball drifting through space. Snowball Earth. Life survived, barely huddled around volcanic vents at the ocean floor, in the only pockets of liquid water remaining on a frozen planet. The first mass extinction was not caused by an asteroid or a volcano. It was caused by life, by the most successful organism in history, accidentally poisoning its own world with the waste product of its greatest invention. Sound familiar? 538 million years ago, after billions of years of patience and near extinction and slow incremental change, evolution lost its mind. The Cambrian explosion. In geological terms, in the compressed time frame of Earth's history, what happened next was instantaneous. In approximately 20 million years, the animal kingdom went from soft, simple, eyeless organisms drifting in shallow seas to an explosion of body plans, predation strategies, and sensory systems that established the basic blueprints for almost every animal alive today. Here is what triggered it. Eyes. Before the Cambrian, the world was effectively blind. Organisms could sense chemical gradients, pressure changes, temperature shifts, but no creature could see another creature coming. When the first light-sensitive cells converged into a functional eye, the entire nature of survival changed in an instant. Prey could see predators. Predators could see prey. The selective pressure this created was unlike anything evolution had experienced before. Every organism either adapted or disappeared. In the Cambrian Ocean, the first true apex predator appeared, Anomalocaris, reaching nearly a meter in length in a world where most creatures measured in millimeters. It had large compound eyes, grasping appendages lined with spines, and a circular mouth that closed like a camera iris around prey. It hunted trilobites, small armored arthropods, crushing their shells and consuming them whole. For the first time on Earth, something was being chased. Something was dying in terror rather than simply ceasing to function. Predation invented the future. Every adaptation that followed, armor, speed, camouflage, intelligence, social behavior, was invented in response to predation. The entire complexity of the animal kingdom exists because something decided, 538 million years ago, to eat something else. Violence, it turns out, was the engine of everything beautiful. 251 million years ago, Earth came closer to being completely sterile than at any point since the origin of life. The Permian mass extinction scientists call it the Great Dying was the most catastrophic event in the history of complex life. Not the asteroid that killed the dinosaurs, not Snowball Earth. This, 96% of all marine species, gone. 70% of all terrestrial vertebrate species, gone. Entire ecosystems, evolutionary lineages hundreds of millions of years in the making, wiped from the fossil record in what amounts to a geological instant. The cause was in Siberia. A system of tectonic rifts tore open across the Siberian Craton, an ancient, stable section of continental crust, and what erupted was not a volcano. It was a volcanic province. Magma flooded the surface across an area equivalent to the continental United States, erupting continuously for approximately 1 million years. But the lava itself was not the primary killer. It was what the magma cooked on its way up. The Siberian lava flows passed through thick deposits of coal and oil, the compressed organic remains of the Carboniferous period. As the magma heated these deposits, it released trillions of tons of carbon dioxide, methane, and sulfur dioxide directly into the atmosphere. Global temperatures rose 10 degrees. The oceans acidified. The oxygen content of seawater dropped so severely that the deep oceans became completely anoxic dead zones where nothing could survive. Hydrogen sulfide, produced by the anaerobic bacteria that thrived in the oxygen-depleted water, bubbled up through the ocean surface and into the atmosphere, poisoning the air. The ozone layer was destroyed. Ultraviolet radiation poured through unfiltered. The planet did not die, but it came close enough that the distinction barely mattered. What survived was almost nothing. A few small, burrowing, generalist species creatures that could hide underground, eat almost anything, and tolerate conditions that killed everything else. From those survivors, the next chapter of life would be written. After the Great Dying, the ecological gaps left by the extinction of 96% of species were enormous. Evolution rushed to fill them. The archosaurs, a group of reptiles that had survived the Permian catastrophe in small, unimpressive forms, began to diversify at a rate that had no precedent. Within 10 to 15 million years of the extinction event, they had split into two lineages that would define the next 160 million years. One lineage became the crocodilians. The other became the dinosaurs. For 160 million years, a duration so vast that it makes human civilization look like a rounding error, the dinosaurs dominated every terrestrial ecosystem on Earth. Not in one form, not as a single body plan, but in an extraordinary diversity of sizes, behaviors, and adaptations that we are still discovering. Consider the scale of the largest. Argentinosaurus, a sauropod from South America, may have reached 100 tons in weight. Its heart was the size of a small car. Its neck stretched 15 meters into the canopy of Jurassic forests. When a herd of these animals moved, the vibration could be felt kilometers away through the ground. They were not merely large, they were geological events with legs. Consider the terror of the most efficient. Deinonychus, the real inspiration for the velociraptors of Jurassic Park, though the movie got the scale wrong, hunted in coordinated groups, using a sickle-shaped claw on each foot to anchor into prey, while its jaws and hands tore it apart simultaneously. Its brain, relative to body size, was among the largest of any dinosaur. It planned, it coordinated, it communicated. And consider the apex of it all. Tyrannosaurus rex appeared in the final 2 million years of the dinosaur era, a species so specialized, so refined by millions of years of iterative evolution, that it represented the absolute peak of terrestrial predator design, binocular vision for precise depth perception, a brain large enough for complex hunting behavior, and a bite force of up to 57,000 newtons, the strongest of any land animal before or since delivered, through 60 banana-sized serrated teeth designed not to cut, but to crush, to shatter bone and marrow in a single application of force. For 160 million years, this lineage ruled. And then, on what amounts to an ordinary afternoon in the late Cretaceous, the sky changed. A rock 10 kilometers wide entered Earth's atmosphere at 70,000 kilometers per hour. It was traveling 60 times faster than the speed of sound. The air in front of it compressed so rapidly that it superheated into plasma, a flash of light brighter than the sun, visible from thousands of kilometers away, before the sound had even begun to travel. It struck the shallow waters of what is now the Yucatan Peninsula in Mexico. The energy released was 100 million megatons, billions of times more powerful than every nuclear weapon ever built, detonated simultaneously. In the first second, a flash of thermal radiation incinerated everything within 1,500 kilometers. Not burned, vaporized, converted directly from living matter into superheated gas. In the first minute, a shock wave of compressed air moving faster than any hurricane tore across the North American continent, uprooting forests, flinging animals like leaves. In the first hour, the impact ejected billions of tons of molten rock into orbit. As Earth's gravity pulled this material back down, it re-entered the atmosphere across the entire planet, simultaneously heating the upper atmosphere to hundreds of degrees, igniting forests on every continent through radiant heat from above. The entire surface of the Earth caught fire, at once. And then came the darkness. The soot from burning forests, the sulfur from vaporized rock, the dust from the impact, all of it combined into a global shroud that blocked sunlight completely, for months, for years. Without sunlight, photosynthesis stopped. Plants died. The food chain collapsed from its base upward. The giant herbivores starved first. Then the carnivores followed, including Tyrannosaurus rex, which required hundreds of kilograms of meat per week to sustain a body it could no longer feed. The 160 million year empire ended in darkness and starvation. 76% of all species on Earth were erased, and in the burrows beneath the frozen, ash-covered ground, small, warm-blooded, fur-covered creatures waited for the sky to clear. The mammals that survived the asteroid impact were small. Most weighed less than a kilogram. They ate insects, seeds, and the remains of the dead. They were not impressive, but they had something the dinosaurs never developed to the same degree: warm blood, insulating fur, and the biological capacity to nurse their young to produce milk, to invest enormous parental energy in ensuring offspring survival, rather than simply producing large numbers and abandoning them. This parental investment created the conditions for something unprecedented in Earth's history: the intergenerational transfer of learned behavior. Mothers teaching offspring. Offspring improving on what they learned. Knowledge accumulating across generations. As the planet recovered, mammals diversified with breathtaking speed. Within 10 million years of the extinction event, the basic body plans of every modern mammal group had appeared. Whales returned to the ocean. Bats took to the air. Horses, elephants, primates, all emerged from the same small, burrowing ancestors that had survived in the dark. In Africa, one primate lineage made a forced transition. Climate change shrank the forests they had lived in for millions of years. They were pushed onto open savanna, exposed, slow, physically unimpressive, surrounded by predators that were faster and stronger than they were. They stood up. Bipedal locomotion freed the hands. Free hands, combined with increasingly complex social groups and expanding brain capacity, created the feedback loop that has no parallel in biological history. Intelligence, improving the conditions for more intelligence. Tools, fire, language, agriculture, cities, science, all of it. From that first terrified primate standing upright on an African savanna to the James Webb Space Telescope, sending back images of galaxies 13 billion light-years away, compressed into the final fraction of Earth's history, 4.5 billion years. A molten hell that assembled itself from space dust. An ocean that appeared after 1,000,000 years of rain. A single cell that learned to copy itself in the dark at the bottom of that ocean. A planet that froze solid, that burned, that was struck by space rocks, that lost 96% of everything. It had built 5 separate times and rebuilt itself each time from what remained. 160 million years of dinosaurs, gone in a single afternoon. And then us, in the last heartbeat, in the final fraction of a second of everything that came before. We are not the point of this story. We were not inevitable. We were not planned. We are the product of a chain of catastrophes so long and so improbable that the odds against our existence are effectively incalculable. And yet here we are, sitting in the rubble of 5 mass extinctions, breathing oxygen that was once a poison, living on a planet that was once entirely on fire, descended from a creature that survived the death of the dinosaurs by eating their remains in the dark. The story of Earth is not a story about us. It is a story that we accidentally survived. And the question of what we do with that survival, how we use the intelligence that was built on 4.5 billion years of catastrophe, is the only question that remains unanswered. The clock is still running. Which moment in this 4.5 billion year story hit you the hardest? Tell me in the comments. I read every single one. If this video changed how you think about where you come from, share it, subscribe and turn on notifications. Next time, we zoom in on one specific moment in this story and go much, much deeper.